We've already seen that the differences in economic growth between two nations is in part due, or in large part due, by the institutions and the rules of the game. But we want to look at a more formalized model of economic growth. So we're going to look at the Solow model. We're going to look at how economic growth and the savings rate determine differences in growth rates between two different countries. So we're going to start off with our production function, GDP, Y, is equal to alpha times some function of capital and labor, and that E is going to be for effective labor. So we're going to see that alpha represents ideas, capital is capital, K is capital, L is labor, and then E is an effective labor, and it's a measure of technological progress. So alpha is more about how ideas happen in an economy. People alter the way they produce things, and E is effective labor, some sort of technological progress, such as computers and the way they've been used, and we look at the internet, things like that. So we're going to assume for the moment that both alpha and E are equal to 1, so our production function is just Y GDP is equal to some function of capital and labor. And if we divide both sides of that equation by L, we get Y divided by L equals some function of capital over labor and the 1. And so we're going to just say that we can write this equation as output per worker is going to be equal to some function of capital per worker. And we can see from this graph that there is a strong correlation. It's an absolute correlation. The more capital per worker a country has, the higher the per capita GDP. And we see this growth throughout countries. If we look at the first derivative of our production function, we're going to see it's positive, which means as you add more capital per worker, output per worker increases, just like we see in the graph. However, the second derivative is negative. And what this simply means is if you add more workers, add more capital to a fixed number of workers, output does increase, but it increases at a decreasing rate. And this we call, of course, diminishing marginal product. We saw this with labor. As we add more workers to, say, a kitchen, holding capital fixed, the amount of food that's produced increases, but at a decreasing rate. And that's, of course, the diminishing marginal product of labor. Well, the same thing happens with capital. If you add more capital to a fixed number or fixed quantity of labor, then output increases, but again at a decreasing rate. So this is the diminishing marginal product of capital. We can see this if we draw out the production function. Here's our production function for Y is some function of capital. It's increasing throughout as you add more capital per worker on the x-axis. Output per worker on the y-axis increases, and that's the positive first derivative. But the negative second derivative shows that as you increase more capital, output's increasing, but again at a decreasing rate. So let's take a look at a poor country here in teal. It has K1 units of capital per worker and gets Y1 units of output per worker. And a line tangent to the slope of the production function at that point is very steep. So if you add one more unit of capital per worker, output increases significantly relative to, say, a rich country where we have K2 units of capital and Y2 units of output in the orange. That's a much flatter slope. And so as you add more capital to the rich country, output increases, but not as rapidly as if you're adding one more unit of capital to the low-income country. And we can see this when we look at different countries. If we add one more tractor to the United States, output's going to increase, but not by much relative to what we already have. But if you had that tractor in a low-income country, output would increase significantly because they would have fewer people using hand tools and now moving to more modernized capital. So let's say we use as our equation Y is some function of capital. Let's say that function is the square root of capital. So if you have 4 units of capital per worker, output is 2 units per worker. If you have 9 units of capital per worker, output is 3, 16 and 4, 25 and 5, 110, and 420. And so output is increasing as you add more capital per worker. The first derivative of this, now keep in mind, we are not taking the absolute change between, say, 4 and 9. So if we were going to look at the change in output with respect to a change in capital, the change in output would be 1, change in capital would be 5, it would be therefore 0.2. We're looking at the discrete change right at that point of 4 units of capital and 2 units of labor, and that's equal to 0.25. At 9 is 0.167. Notice that each one of these is positive, but that number is going down for each unit. And so it's increasing, but at a decreasing rate, and that shows up in our second derivative, where each time it's negative because we're increasing, but it's less than what the change was in the preceding unit. So this is what we mean by its output is increasing, but at a decreasing rate, and that gives us a shape of our production function. So if we start with the Solow model as a closed economy, there are no imports, so net exports is equal to 0. We're also going to assume no government. So G is equal to 0. And again, is this a fair assumption? Well, we're going to basically say government is an exogenous variable, and we're going to hold that out right now. And so therefore, GDP is equal to, this is again our consumption part of this, what we produce, we either consume or we invest. So everything we produce, we consume or invest. And if we divide both sides of that equation by L, so this matches our production function, remember this is our consumption now, if this matches our production function, Y divided by L is output per worker, and if we divide the right side of that equation by L, we have consumption per worker plus investment per worker. In order to invest, though, we do need savings. So we're going to say S represents the percentage of our income that is saved. Again, this is not the interest rate. This is the percentage of our income that we put away and we don't consume. So if we're only consuming or investing and we say consume 80% of what we produce, then savings would be 20%. It's not an interest rate. It's simply that percentage of our production that we put into savings and therefore investment. So again, Y output per worker is equal to consumption per worker plus investment per worker. We can rearrange this equation to show that what we invest is our income left over from what we consume after we consume, or we can say consumption is what we get after we've invested our output. So we consume a percentage of our income that remains after saving. So we can say that if we save 20% of our income, then we must consume 80%. That's the 1 minus 0.2 is 80% of our income. And since savings in a closed economy, savings equals investment, so savings must equal output minus consumption. Savings, therefore, is equal to output per worker minus 1 minus S, whatever's left over from savings times output per worker. And we can rewrite that to get output per worker minus output per worker is equal to savings per worker. And really, this is just saying that savings is some fraction S times output per worker. So we can draw this up in just a second, but we'll see that investment then is going to be savings times our production function, whatever is left over from that consumption where we're at capital per worker. So let's start with our production function again, and we now add savings, and this is the percentage of our savings of our production that we don't consume. And therefore we say savings rate times output per worker or some function of output per worker, and this lets us know how much we save after production. So at this point here, K1 units of capital per worker gives us Y1 units of output per worker. This is what's invested, this is what is consumed, and this would be our production function plus our consumption, showing how much we're going to consume and produce using the Solow model. We're going to come back and look at the actual, some differences or additions to this to see what happens when capital depreciates and we add more people.